to talk to. Jenny Taylor is a second-year student nurse who is undergoing rotation in your department. Other information you have about the nurse. She has been on the ward for a few weeks and she would like to learn how to read an ECG. She knows how to perform an ECG. What you must do: teach the student nurse the basics of ECG. So this nurse, when you ask her what she knows about an ECG, she will tell you, I know how to take an ECG, I know the ECG machine, I know all about the 12 leads, I know everything. It's just how to read the ECG, doctor. She will ask some questions. What do I need to look for on an ECG? And why do you normally perform an ECG? Then she has got some ECGs with her, which she may show you, okay, I had these ECGs from the patient, so what exactly is happening with this patient? She's happy and she's positive in the station. When you go and look in the station for the setup, there is a paper and a pen, obviously for you to draw and teach her about an ECG. The nurse is there, obviously wearing the blue top, which nurses usually wear. She's holding 4 ECGs in her hands. She may give you any of the ECGs, so you need to know how to read an ECG. Approach. Greets as normal. Introduce yourself with your first name. My name is Samson. I'm one of the FY2s in the department. Okay. Establish the reasons of the discussion. Explain that I understand that you like to learn, you like to learn how to read an ECG. Yes. Okay, so I'm sure I can help you with that. Okay. Can I just ask you a few things, before we start talking about how to read an ECG? So what do you know so far about ECG? Well, I know it has got 12 reads. I know how to take it. I know how to use the machine. I just don't know how to read and what to look for. Okay, I'm sure I can help. Okay, shall we start? Then you're going to have to start explaining. So I'm going to show you here and talk through an ECG. Okay, so if we look here, what we see in here is obviously an ECG. Okay, so you're going to have to draw for the nurse this ECG. Okay, so this is basically an ECG. Yeah. So this is a P wave. So there are some waves. This is a P wave, and after the P wave, there is a Q wave which goes down. Okay, there is a Q wave which goes down, and then there's an R wave which is usually positive up, and then going down here is an S wave. Then this is an isoline. On the center here is what you call an isoline, neutral line. Then after that, this is a T wave. Now, what do these represent? The P wave represents contraction of the atrium. The QRS complex represents contraction of the ventricles. The T wave usually represents repolarization. Okay? It's like a refilling back of the ventricles. So you should have a P wave, a Q wave, R wave, S wave, and T wave. This is a repolarization of the ventricles. Is that clear so far? Yes. Now, what we need to be looking at is obviously the significance of these waves. So if you have got a P wave present before each QRS complex, as you can see here, there's a P wave, here's a P wave. It is usually located before each QRS complex. If it is present, it means it's a sinus rhythm. Sinus rhythm. If it's not present, it means it's a non-sinus rhythm. Because in the normal, the SA node is producing impulses. Is that clear? Yes. Next is a Q wave. The Q wave can be present or may be missing. If it is present, then it is important to assess the size of the Q wave. The normal size, it must be less than 1/4 of this height. Must be less than 1/4 of the R wave. If it's less than 1/4, it is normal. Or if it is not present, it is also normal.
Not present or less is also normal.
It can only make significance as a complex. Then the T wave as well, it will be there. If it's not there, it may mean other things. If it is too tall, it may mean other things, pathological problems as well. Like what, doctor? If it is too tall, you start thinking about it, high potassium in the blood, hyperkalemia, 20 waves. Is that clear? Yes. The next thing that you need to be thinking about is the segments. So I've got the PR interval. Okay? The PR interval is obviously the distance from the beginning of the P wave sorry about that, the distance from the beginning of the P wave, okay, to here, the R wave, the beginning of the R wave or the Q wave. This distance, if it is too long, then we would say there is a what? There is a prolonged PR interval, is a first degree heart block. Okay? Then the other distance we need to be looking at is obviously then the QT. From the beginning of the Q wave to the end of the Q wave, the QT interval. Now this interval is the time taken for the ventricles to contract, which is called depolarization, including repolarization. If this is too long, it may signify serious heart condition, which may cause usually common in young people congenital problems, which may cause somebody to suddenly collapse and die. So it's called a long QT syndrome if it's too long. Okay. The other one is ST, the beginning of S to T segment. Okay. Now, what we're interested in is this line here. This is called an isoline on the center. If this is segment from here to here, the ST segment is up, we say it's ST elevation. If it is down, we say ST depression. It usually indicates heart problems. If it is down, ST depression, it indicates angina or ischemia. If it is high up, it indicates ST elevation, it's an MI. Is that clear? Yes. So we've looked at the three segments, the PR interval, the QT, and the ST. So usually if there's some changes, they do signify things. Is that clear? Yes. The other one is obviously the heart rate. You look at the distance between R wave to the R wave. Okay. Do you have I can see of some ECGs, the names of some ECGs. Ask if you can use one of the ECG. You take a normal ECG and tell her how to calculate the heart rate. So if you look at this ECG, these are the R waves, and there go some P waves in there. So the distance from R wave to R wave, okay, you need to check that it is the same all the way throughout. If it is the same all the way throughout, this distance, we say it is a regular reading. If it is not the same, it varies from time to time, then it is irregular. Okay? Now, we need to calculate the heart rate. If the rhythm is regular, then we can easily calculate the heart rate by dividing. Heart rate equals 300 divided by number of big boxes between two QRS complexes. So let's look at this one. Look, the big box is 1, is 2, 3, 3. So 1, 2, 3, almost 4. Okay? So if you say it is 4 completely, so you can say 4.5. So 300 divided by 4, in here, it gives us a 75. So the heart rate will be 75. If the big boxes are 3, then you do 300 divided by 3. So depending on the number of big boxes between the R waves. Now remember, one big box contains small 5 boxes. So you take the big box and you use this formula only if it is regular. That is it. The distance between each QRS complexes is the same throughout. 300 divided by big boxes between the QRS complexes. Is that clear? Yes. If it is not irregular, the distance here is different, the distance there is different, then you want to know which boxes to pick up. In that situation, then you would need to count 30 big boxes. Let's start from here and count 30 big boxes. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So what do I have in here? 30 finishes here. Now, in this 30, I'm going to put a line. In this 30, how many QRS complexes are there? 1, 2, 3, 4, 5, 6, 7, 8. So you do 8 times 10, which is 80. So the heart rate is 80. Now remember, using this formula, we said it was a 300 divided by 4 because there are 4, which was 75. So you can see it's almost similar. But if the rhythm is irregular, you count 30 boxes and find how many QRS complexes lie within those 30 boxes and you multiply it by 10. Is that clear? Yes. Okay, so by now, we can say when it's sinus rhythm, whether it is regular or irregular, we can tell where there's there's a P wave, no P wave, the ST segment, we can tell them. Is that clear so far? Yes, is there anything else you want to ask at the moment? Okay, so there is quite a lot we can look through the ECG, but it usually takes time, so we can try to build up from time to time. Next time we meet, we can look at other things as well. Avoid overloading information. Okay, doctor, I've got some other ECGs. Can you help me? What is on this ECG? Patient may give you some ECGs. Okay? So, what about this ECG? Well, this ECG, let's look at it. Okay? Let's look in here. First, look at the P, sinus. There's a P everywhere, sinus reading. Does it look regular? 1, 2, 3, 4, 1, 2, 3. It is regular. So this is a normal sinus reading. It looks like a normal ECG. Yeah? Nothing to worry. Okay, I've got another one. Doctor, what about this one? Okay, so first and foremost, obviously, we need to look for obvious abnormalities. Is there anything obvious? What is obvious in here is an ST elevation. You see, there's an ST elevation in lead 2, lead 3, and AVF. This is a classical ST elevation, in the inferior wall. So it's an inferior wall myocardial infarction, because ST elevation, lead 2, lead 3, and AVF. Inferior wall myocardial infarction. Let's look at other types of, obviously, other type of MI. We look at this one, an ST elevation as well. Lead 2, ST elevation. Lead 3, ST elevation. Lead 4, lead 5, lead 6. If you look in lead 1 and lead AVL, is ST elevation as well. So this is an ST elevation, ST elevation. So having anterior lateral MI. Okay. The lateral wall is V5, V6, lead 1, and AVL. The anterior wall, obviously, V1 to V4. So here from V2 all the way to V6 plus lead 1 and AVL, there's an elevation, as you can see. In here as well as in AVL. So it's anterior lateral MI. Okay. So this one, again, an ST elevation. It's an ST elevation, as you can see. Lead 2, there's ST elevation. Lead 3, and AVF ST elevation. So lead ST elevation, lead 2, 3, and AVF is inferior myocardial infarction. This one, the one you have, what we can see in here, obvious abnormalities, is a T. The T wave are too high. Okay? If you look in here, QRS complex, this is T. It's too tall. Very tall T wave, suggesting hyperkalemia. Okay? So we need to be thinking of hyperkalemia in this one. Let's look at the other ECGs. Now, the other ECGs, this one, this is the same way we've looked at. Okay? The tall T waves, the tall T waves everywhere, suggesting, hyperkalemia. Now, a few other ECGs that you might look may present special interest. Let's look at this one. This is the other ECG in here. If you look at this ECG, is there a P wave? Here there is no P wave. Here looks like there is a P wave. Here looks like there is no P wave. Like there is a P wave. So there is no pattern. But the QRS complexes, if you look at them, how many big boxes? 1, 2, 3, 4, 5, 6, 6.5. Every time 1, 2, 3, 4, 5, 6. So they're about 6. So every time is the same, 6, 6. So the QRS complexes are regular. So it's a regular rhythm, but the P wave is sometimes there, it's not there. So if the QRS complexes are regular and the P wave does not seem to be there every time, you need to think of a complete heart block. So what do? What you do is to find where you can clearly see the P waves. So let's say this is a P wave. This is T. And there is another P in here. So possibly this is a P wave. That's why it is absent here. So what we're going to do, we're going to mark this distance from here to there and row it over the rest of the ECG to see if we're going to see the pattern in the P wave. Because usually the P waves, they are regular on their own and the QRS complexes are regular on their own as well. So you need to take a piece of paper. So 1 second. I'm going to take a piece of paper. Now, this is my piece of paper I have taken. Okay. So what I'm going to do in this piece of paper, what I'm going to do on this piece of paper is to mark 2 obviously P waves. Now, in this case, Here, this is a P wave. So I'm going to mark it here as a P wave. This looks like a T, but this looks like a P wave. So I'm going to mark it here as a P wave. What I'm going to do in this particular case is to keep sliding it to see if I will see the pattern in the P wave. So have a look. I'm going to slide this to the next P. Yes, it follows. There's another P wave there, as you can see. Slide it to the next. Another P wave there, you see? Slide to the next. Another P wave there. Slide to the next. Another P wave there. So we have established a pattern. The P waves are regular, but the QRS complexes are also regular. So this is a complete heart block. Regular P waves, which are falling everywhere, and the QRS complexes are also regular. So it's a classical, obviously, complete heart block. Well, you don't need to go through the ECGs with a mess. You may run out of time, but explain them slowly the principles. Tell them next time we can add extra information. But be ready, she may give you some of the ECGs she has in her hands for you to say what is there. Thank you.
Okay, guys, thank you. We'll go and have a look at the